Hello everyone, welcome back to the channel. This is another video in our data structure algorithm series. As we already know, we are discussing the topic linked list, right? And we already discussed about how do you add the nodes in the linked list at the beginning and end of the linked list with some other methods. Now in this video, we are going to understand how do you remove a node from a linked list, right? Understand how do we remove the node at the end of the linked list. So let's implement it right away. Public int, I'm giving the return type as int because whatever nodes we are removing, right, I want to return the value of that particular node as well, right? If you are getting the value as a return type, right, at that time you will be sure, okay, from my linked list this is the value which got removed, right? So let's implement that method, which is remove last. I'll be explaining you things as I implement. So first, what do we need? First, we can check if our linked list is empty or not. Okay, let's check it right away. So if our list is empty, then throw new, no such element exception, list is empty, right? Now let's think of a case when you have only single node in your linked list, right? So what will be that case? How will you know if you have a single node in a linked list? I have already explained you, right? If your linked list has a single node, that means your head and tail, both pointer of the linked list are pointing to the same node. That's how you will know that you have a single node in the linked list. That means if you have head is equal to tail, that means you have a single node in the linked list. You can make size as 0, and then okay, we also decided we are going to return the element, right? So for that, what we can do, int removed element is equal to head dot value, right? So this is the value which is being removed, right? We already able to hold it in a particular variable. Now we reduce the size, and now what we want to do, we want to set head and tail both to null. That means again we made our list as empty, and we are returning this removed element. Now this is feasible when your list has only single node, right? So far we talked about two scenarios: when your list is empty, and when your list has only single node. Now let's imagine the scenario when your list has multiple nodes, right? Let's say 2, 3, or even more than that, right? In that case, what will happen when you're trying to remove this last node, right, which is tail node? You need the previous node, like the node which is immediately before the tail node, right? So for that, how you will know that? You need somehow a pointer that points to the previous node. How do you implement that? Let's see. Let's make two pointer for now, which is current, that points to our second node, let's say, because we already know there are at least two nodes, right? And we take one more node, which is previous node, and this points to current node, right? So that both nodes are in place right now. So our current node points to the second node, and previous node points to the current node, which is the first node, right? Now let's iterate while current dot next is not equal to null. What we are supposed to do? We are supposed to set current, we are supposed to set previous to the current node and current to current dot next. Let's talk about this code what you have written now, right? If current dot next is not equal to null, that means it's a second last node, because if current dot next is equal to null, right, then it's a last node itself, because last node, that is tail node, its next point to null, right? Going till second last node, and we are setting previous to the current node and current node to the next node. That means at the last iteration, this current will point to the last node, and previous, in this previous pointer we will have the previous node. Now what we want to do, we want to change the pointer of tail to this previous node. Now this previous node is became the tail node, right? We know tail is the last node in the linked list. Now what we did, we figure out this is the previous node, and we made sure the tail points to previous node. Now we know that last node is still there. So what we do, we made tail dot next is equal to null. The moment you make it null, right, the last node now has no links. So that becomes eligible for garbage collection, and that node gets deleted basically. So the moment you make it null, right, there is one more thing that you need to do, which is size minus minus. That why we are doing it here, because we can also make it size minus minus, that's correct. So when there is a single node, right, we know that size will become 0 after removing it. That's why we strictly written 0. Even if you write size minus minus, right, that's also fine. So here, after getting the previous node, setting the tail to previous node and setting the its next to null, we were able to remove the last node, and then we reduce the size by 1. And now at the end what we do, we return the removed element, right? So now we are able to return this element that we have removed, right? So this is the code, complete code. Let me give you a summary once more so that you understand it properly. So we implemented remove last method, and what we are trying to achieve in this particular method, we are trying to remove the last node from the linked list, right? For that, first we check if our list is empty. If it is empty, we just straightforward thing, no such element exception, list is empty. Now we are talking about a scenario when there is at least one node in the linked list. That's why we are able to hold its value, right, in our removed element variable. So otherwise, if you put it even before this checking if the list is empty, right, you might get a null pointer exception, because if the list is empty, your head will point to null, and if you call any value or method on top of null variable, right, you will get a null pointer exception. That's the reason it is at 58 line number. That is after we check that our list is definitely not empty. So first we check for the empty case, second we are check for the when we have single node in the linked list, right, and then we check for when we have more than one node in the linked list. When we have more than one node in the linked list, what we did, we created two pointers. First pointer points to the second node in the linked list, and another pointer which is called previous points to the current node, that is first node in the linked list, right? And then we iterated until the second last node. Remember, it's the second last node, right? Because if the current dot next is equal to null, it becomes the last node. Okay, so we iterated till the second last node, right? And we, with every single iteration, our current pointer changes to previous and current goes to the next pointer, right? Basically what we are doing, we are assigning the whatever we have in our current node, that we are assigning to our previous node, and current jumps to the next node, right? When we reach our second last node, right, that's when what we are doing, we are assigning that previous node to our tail node, so that previous node, whatever we are able to calculate, now that is our tail node. The moment we do tail dot next is equal to null, your last node of the list gets removed, and we reduce the side, and whatever the value of that particular node was there, right, we just return that particular value in the return type. Now I see is as part of these lines, right, what we are doing, so we are just calculating the previous node, right? So if we want to increase the readability of our code, right, we want to make it more readable, so that whoever reads this code, they don't think like, okay, what the hell we are doing with the nodes and nodes, right? So let's make it more readable. let's refactor, extract it into a method. Let's call it get, yeah, get previous. That's enough. See, IntelliJ is really smart IDE, to be honest, right? So we created a method which is get previous. Now in get previous, what we did, we just extracted that code. That's it, nothing else we did. We just copied that code, created a method called get previous, and pasted those lines. And whatever value was there in the previous node, we just straightforward returned it. So as in this particular previous node, right, previous variable, we are holding the previous node, and we are setting that to a tail node, setting the tail dot next to null, and reducing the size. That's it. So why we did that? We made our code more modular, and now even our remove last method is more readable. We are able to read, okay, if our method is if our list is empty, we are throwing the exception telling the list is empty. If we have single element in our linked list, then we are just setting it to null and reducing the size, right? If we have more elements, we are calculating the previous node, right? Deleting the last node, reducing the size, and returning the whatever element we have removed from the node, from the linked list. So yeah, that is the implementation of remove last node. Let's see if I'm just telling you a story or if it actually works. Now let's try our code. Let's see what do we have in our linked list right now. I think we should have 40, 10, 20, 30, right? So yeah, so the structure would look like, currently the structure is like first node is 40, second is 10, third is 20, and fourth node is 30. So if we are removing the node from the last of linked list, that case 30 should be removed and 40, 10, 20 should be there. Let's see if that is the case, if we did everything wrong, if we did everything right. Okay, list dot remove last. So let's see first what is the element that got removed, right? Because that is why we made the return type as int, right? See, wonderful, 40 got removed. How? You see, you're getting 40, which is the wrong answer, correct? Now why it is wrong? Because when we have multiple nodes in our linked list, right, when the value that we are storing in our removed element is from the head, right? And the head is the first node, which is 40 when we added all these nodes, right? So when there are multiple nodes, that case what we are supposed to do, that is, this is the line that I have added later. When there are more elements, we are reassigning the value to our removed element variable, which is previous, whatever previous node we got, right? Its next node, which is the last node, its value we are holding in this particular removed element. We are actually reassigning the removed element value and we are returning that. That's it. And this we did because we wanted to return the value of the node that we are removing. That's it. So now if I run it again, we are supposed to get 30, right? So you see, this time we got 30. That means our implementation is correct. Let's try it one more time. So this time what we should get? We should get 20. So if we did everything right, we should supposed to get 30 and everything should be fine. Yeah, perfect. Let's remove one more time. And one more time. Now we are supposed to get 10 and then 40, right? So I think everything in the list is removed now, right? If we try removing the element again, right? Let's see, we are supposed to get an exception that list is empty, right? And we are getting that as well, right? No such element exception, list is empty. So I hope you understood this implementation, right? This was a really interesting method, to be honest, because a lot of algorithms that I'm going to teach later will be based on this iteration that we are doing here, where we are trying to find the previous node and all that, right? So this was one of the very interesting implementation. where we had checked for the first the empty list, then we checked when there is only one node, and then we iterated to find the previous node. Then we adjusted pointers accordingly, we adjusted size accordingly, and we were able to return the element as well that we are removing right now. So yeah, this is a written code including the concepts of readability, modularity, and all those things. So understand it properly. If you have any doubts, feel free to comment. If you understood, feel free to like and subscribe, right? See you in the next video. In next video, we'll be talking about another method. So in this video, you understood how do we remove the node at the end of the linked list, right? And now in the next video, we'll understand how do you remove the node from the beginning of the linked list. And removing the node from the beginning of the linked list is very easy, right? So this was actually O of n operation because we are iterating in the last node, right? So that's how it becomes the O of n operation. That means you are iterating through all the elements from the linked list. Whether in the next video where we are removing the node from the beginning of the linked list, right? There you will see we are completing that operation in O of 1, that is constant time. So yeah, let's understand this first, right? If you understand it, the next video is just piece of cake for you, right? So yeah, I hope you are able to understand this implementation. It was a really interesting code for me when I understood it for the first time. Let's give it a try. Let me know if there are any complexities in it, and see you in the next video. May the source be with you.